Imagine a date etched into the annals of human history, 2030. Not for a war, not for a discovery here on Earth, but for something far grander. Picture yourself not on a video call, but standing on a crimson landscape, the dust of an alien world beneath your feet, a breathtaking, desolate vista stretching to the horizon. The very air you breathe, painstakingly synthesized, is a testament to an impossible dream made real. How did humanity get here, so far from home, establishing a foothold on another planet? The answer, a marvel of engineering and unwavering human ambition, stands tall and gleaming, a beacon against the Martian sky. It's not just a rocket, it's a testament to our relentless drive to touch the stars, the SpaceX Starship Block 3, a vessel designed not just to visit, but to inhabit the cosmos. This isn't just about a journey, it's about a new era, a bold declaration that humanity is no longer bound by Earth's gravity. For decades, the idea of regular interplanetary travel remained a distant fantasy, confined to the pages of science fiction. But then came SpaceX, a company born from a vision to make humanity a multiplanetary species. Their journey began with Falcon 9, a revolutionary reusable rocket, then scaled up to the mighty Falcon Heavy. Each launch, each successful landing, was a step, a crucial building block in a much larger, more audacious plan. They learned, they iterated, they pushed the boundaries of what was thought possible, always with their sights set on the true prize, Mars. The Starship, in its earlier iterations, underwent countless tests, faced numerous challenges and experienced failures that, to the uninitiated, might have seemed like setbacks. But for SpaceX, each anomaly, each fiery descent was a lesson, a piece of the puzzle that brought them closer to their ultimate goal. These weren't failures. They were painful, expensive, yet indispensable data points on the path to unprecedented success. And from this crucible of innovation, this relentless pursuit of perfection, emerged the most advanced version yet, the Starship Block 3. The Block 3 isn't merely an upgrade, it represents a fundamental leap forward, incorporating years of hard-won lessons and cutting-edge design philosophies. Previous Starship prototypes, while groundbreaking, were proving grounds, experimental platforms designed to validate concepts and iron out kinks. The Block 3, however, is engineered with a singular purpose: to be the workhorse of deep space exploration. Its refined structure, optimized for both atmospheric re-entry and deep space vacuum, speaks volumes of the detailed engineering that has gone into its creation. From the subtle curves of its aero shield to the intricate internal architecture, every element has been meticulously designed to maximize efficiency, safety, and reliability for missions far beyond Earth's comfortable orbit. This isn't just about reaching space, it's about living and working in space, about forging a path for permanent human presence across the solar system. This latest iteration of Starship is intrinsically woven into the very fabric of SpaceX's grandest ambitions. From the audacious plan to establish sustainable lunar bases as part of the Artemis program, to the truly mind-bending prospect of colonizing Mars, the Starship Block 3 is the linchpin. It's designed to carry not just cargo but hundreds of human beings, alongside all the necessary equipment, supplies, and infrastructure needed to build new civilizations amongst the stars. This isn't some far-off, distant dream. The development of Block 3 signals a tangible commitment, a clear trajectory towards realizing humanity's oldest dream, becoming a spacefaring species. The implications are profound, touching upon everything from resource acquisition in space to the very survival of our species, creating a backup for humanity on another world. The true marvel of Starship Block 3 lies not just in its ambitious mission profile, but in the meticulous engineering innovations beneath its sleek, metallic skin. Years of rigorous testing, countless hours of data analysis from previous prototypes, and an unyielding commitment to pushing the boundaries of material science and design have culminated in a vehicle that is vastly more robust and capable. One of the most critical structural enhancements is the newly designed heat shield. Unlike the cumbersome ablative shields of previous spacecraft, Block 3's heat shield employs advanced ceramic tiles, each precisely engineered to withstand the unimaginable temperatures generated during atmospheric re-entry, whether returning from deep space at hypersonic speeds or making a pinpoint landing on Mars. These tiles are not merely an outer layer, they are an integral part of the vehicle's thermal management system, designed for durability and reusability, a stark contrast to the single-use protection of the past. The ability to reuse this critical component drastically reduces operational costs and turnaround times, making frequent, affordable space travel a tangible reality. Complementing the heat shield is a completely redesigned engine configuration for the Block 3. While previous Starship iterations relied on a varying number of Raptor engines, The Block 3 refines this arrangement for optimal thrust vectoring, efficiency, and redundancy. The positioning and integration of these powerful engines, now primarily the upgraded Raptor 2s, are not accidental. They are the result of extensive computational fluid dynamics simulations and real-world testing, ensuring that every ounce of propellant is converted into maximum propulsion, whether lifting off from Earth's surface, performing intricate orbital maneuvers, or executing a precise propulsive landing on another celestial body. This refined configuration provides unparalleled control, allowing the massive vehicle to navigate through complex atmospheric conditions and execute maneuvers with a precision that was once the stuff of science fiction. The sheer power generated by these engines is enough to propel hundreds of tons, or dozens of humans, across the vast emptiness of space, a truly breathtaking feat of modern engineering. At the very heart of Starship Block 3's incredible power lies the Raptor 2 engine. This isn't just an incremental improvement over its predecessor. It's a powerhouse of a different league. The Raptor 2 boasts significantly increased efficiency, meaning it can generate more thrust from less propellant, directly translating to greater payload capacity and extended mission durations. This enhanced efficiency is critical for deep space missions, where every kilogram of fuel saved translates into more scientific instruments, more life support, or more habitat modules for future colonists. Furthermore, its increased thrust output provides the brute force needed for rapid ascent from Earth's gravity well and for executing complex interplanetary trajectories. The Raptor 2's innovative full-flow staged combustion cycle, a technical marvel in itself, ensures maximum performance while maintaining a level of reusability that was previously unimaginable for such high-performance rocket engines. The sound of these engines igniting is not just noise, it is the roar of humanity's future taking flight. Beyond the raw power and structural integrity, the brain of the Starship Block 3 has also undergone a radical transformation. The upgraded avionics and software systems are a testament to the sophistication of modern computational power and autonomous control. Imagine a nervous system far more complex than any human-designed aircraft, capable of processing millions of data points per second. These systems are paramount for navigation, guiding the colossal vessel through the vacuum of space, across vast distances, and through the complex gravitational fields of celestial bodies with pinpoint accuracy. Landing precision, especially for re-entries on Earth or Mars, is another area where these upgrades shine. The software precisely controls the engines, fins, and thrust vectoring to ensure a soft, vertical touchdown, minimizing stress on the vehicle and its precious cargo. From launch to landing, every maneuver, every system check, every environmental reading is managed by these intelligent systems, ensuring mission success and the safety of the crew. They are the silent, unseen guardians of every voyage. These advancements in avionics extend to the overall spacecraft control, allowing for increasingly autonomous operations. While human oversight remains crucial, especially for crewed missions, Block 3's sophisticated software can detect anomalies, reroute trajectories, and even initiate emergency procedures with a speed and accuracy that no human pilot could match. This level of automation is not about replacing human ingenuity, but augmenting it, freeing astronauts to focus on their scientific objectives and mission goals rather than constantly managing flight systems. The data communication networks within the Starship are also vastly improved, providing real-time telemetry, environmental data, and high-bandwidth communication with ground control, even across interplanetary distances. This seamless flow of information ensures that both the crew on board and the teams on Earth are always aware of the spacecraft's status, prepared for any contingency, and able to adapt to the unpredictable nature of space. The Block 3 isn't just a vehicle, it's a fully integrated, intelligent system, a living, breathing entity ready to face the challenges of the cosmos. The true test of Starship Block 3's revolutionary design will come with its upcoming test flights. These aren't just launches, they are high-stakes proving grounds, moments where years of computational models, countless hours in design labs, and the tireless work of thousands of engineers are put to the ultimate crucible of reality. Each test flight is meticulously planned, designed to push the vehicle's limits, validate its complex systems, and gather invaluable data on its performance in the unforgiving environment of space. The early, dramatic tests of previous Starship prototypes, though sometimes ending in spectacular explosions, were not failures but essential steps in an iterative process, each providing critical insights that have been meticulously integrated into the Block 3. These next flights, however, carry a far greater weight. They are the final dress rehearsals for humanity's return to the Moon and the first voyages to Mars. The world will watch, holding its breath, as this colossal machine ascends, proving its readiness for missions of unprecedented scale and ambition. The potential of Block 3 for lunar missions is nothing short of transformative, especially when viewed through the lens of the Artemis program. NASA, in partnership with international agencies and private companies like SpaceX, is not just aiming for a fleeting visit to the moon, they envision a sustained human presence. The Starship Block 3, with its unparalleled cargo capacity and ability to perform propulsive landings directly on the lunar surface, is the designated Human Landing System, HLS, for Artemis. Imagine not just a small lander for a few astronauts, but a towering vehicle capable of delivering entire habitats, scientific laboratories and crucial life support systems, laying the groundwork for a permanent lunar base. This isn't just about planting a flag, it's about establishing a new outpost for humanity, a stepping stone to the stars. The establishment of a sustainable lunar base will allow for extended scientific research, the development of in-situ resource utilization, or using resources found on the moon, and serve as a vital staging point for even more ambitious deep space journeys. Looking further into the horizon, the long-term vision of using Block 3 for interplanetary travel truly ignites the imagination. While the moon is a crucial first step, the ultimate prize is Mars, followed by the tantalizing prospect of missions to other celestial bodies in our solar system. The sheer volume and mass capacity of Starship Block 3 mean that humanity can finally send missions to Mars that are not just flybys or robotic landers, but sustained expeditions capable of establishing a self-sufficient colony. Envision hundreds of humans along with tons of equipment, supplies, and even entire greenhouses, embarking on a multi-month voyage to the Red Planet. This vehicle makes possible a future where Mars is not just a scientific curiosity, but a second home for humanity. Beyond Mars, the Block 3 could open doors to detailed explorations of Jupiter's icy moons, searching for signs of life in their subsurface oceans, or even audacious sample return missions from the asteroid belt, unlocking secrets that could revolutionize our understanding of the universe. Yet, the path to the stars, even with a marvel like Starship Block 3, is fraught with challenges and uncertainties. The scale of this endeavor is unprecedented, and with it come immense complexities that demand unwavering dedication and meticulous attention to detail. One of the most significant hurdles remains the sheer volume of further testing and refinement required. Each component, from the smallest valve to the colossal Raptor engine, must operate flawlessly in the vacuum of space, under extreme temperatures and enduring intense vibrations. While ground tests provide invaluable data, the true proving ground is orbit and beyond. Anomalies, unforeseen technical glitches, and the brutal realities of space always lurk, demanding constant adaptation and continuous improvement. The iterative development approach, where each flight builds upon the lessons of the last, is essential, but it also means a journey marked by careful, deliberate steps rather than sudden leaps. The public must understand that this is not a finished product, but a revolutionary system in constant evolution. Beyond the engineering challenges, regulatory approvals present their own complex hurdles. Launching a vehicle of Starship's size and power requires stringent oversight from various governmental and international bodies, ensuring safety for both personnel and the environment. The sheer frequency of launches envisioned for a fully operational Starship fleet necessitates streamlined yet robust regulatory frameworks. Furthermore, launch infrastructure limitations are a tangible concern. While SpaceX's Starbase in Texas is a rapidly expanding hub, supporting a global network of deep space launch and landing sites will require immense investment and international cooperation. Building the necessary facilities, from fueling depots to integration towers, across different continents and eventually on other planets, is a monumental undertaking, pushing the boundaries of construction and logistics on an astronomical scale. Each site must be capable of handling the immense forces of a Starship launch and the intricate dance of its landing, demanding precision and resilience. And then there are the unforeseen technical difficulties, the unknown unknowns, that inevitably arise when venturing into uncharted territory. Space is a harsh mistress, unforgiving of even the slightest oversight. A tiny flaw in a material, an unexpected interaction between systems, or a sudden change in space weather could have catastrophic consequences. The human element, too, introduces its own set of risks. Long-duration missions will expose astronauts to unique physiological and psychological stresses, from radiation exposure to the profound isolation of deep space. Developing robust life support systems, radiation shielding, and psychological support mechanisms for prolonged stays off-world remains a monumental task. These aren't just engineering problems. They are challenges that touch the very limits of human endurance and adaptability, demanding innovative solutions and a profound understanding of the human condition in the cosmos. Starship Block 3 is not merely a rocket. It is a profound catalyst for scientific advancement and technological progress, destined to reshape the very landscape of space exploration. Its capabilities extend far beyond simply transporting humans and cargo. By enabling the deployment of far larger and more complex space telescopes, for instance, it could revolutionize astronomy and astrophysics. Imagine observatories with mirrors dozens or even hundreds of meters in diameter, assembled in orbit, capable of resolving exoplanets in stunning detail, peering into the earliest moments of the universe, and perhaps, for the first time, directly imaging signs of life on worlds light years away. The sheer mass capacity means these instruments wouldn't need to be folded up and intricately deployed, but could be built robustly and launched fully assembled or in larger, simpler segments. This radical shift in capability will unlock secrets that currently remain beyond our most ambitious scientific instruments, fundamentally altering our understanding of the cosmos. This is where the story of Starship Block 3 becomes less about engineering and more about the very essence of human ambition. It inspires viewers by emphasizing the possibilities that Block 3 opens up, painting a vivid picture of a future where humanity is no longer confined to a single, fragile planet. The vision isn't just about avoiding a catastrophic event on Earth, but about a flourishing future, a cosmic expansion where human civilization extends its reach, spreading consciousness and culture throughout the solar system. It's about securing humanity's long-term survival, yes, but also about the profound psychological and philosophical shift that comes with becoming a multiplanetary species. The very act of colonizing another world could unlock new scientific disciplines, foster unprecedented international cooperation, and force us to confront our place in the universe in ways we can scarcely imagine today. This journey, however, demands more than just brilliant engineers and massive rockets. It demands a collective will, a shared dream that transcends borders and ideologies. It asks us to invest in a future that might seem distant, but whose foundations are being laid right now, today. The Starship Block 3 is more than a machine. It is a symbol of our species' boundless potential, a beacon urging us to look beyond our immediate concerns and embrace a destiny among the stars. But this dream, this incredible future, will not materialize on its own. It requires the brightest minds, the most dedicated spirits, and the unwavering support of every single one of us. So, what role will you play in this audacious new chapter of human history? Will you be a passive observer, watching from the sidelines as humanity reaches for the stars? Or will you be a part of it, in whatever capacity you can, advocating for space exploration, pursuing STEM fields, or simply sharing this incredible story? The future of humanity is not written in the stars, but forged here on Earth by the choices we make today. This is our moment. This is our chance to become a true spacefaring civilization. The Starship Block 3 is ready. Are you? ***.